Hello, thanks for coming our session. I am Munseong, and this is Oleksii. We are graphics engineers in Samsung Electronics. Today, we are going to speak about next level mobile graphics. First of all, I will introduce our team, Samsung Galaxy Game Dev. And next, my colleague Oleksii will talk about game optimization best practices. And then I will show you our new mobile game analysis tool, GPU Watch. Okay, then let's see about Samsung Galaxy Game Dev. Our team name is Game Dev, so it could be easily thought as game development team, but it is not true. We just support other game company like Square Enix and NCSoft, Nexons and Tencent, and so on. And we also work with engine company like Epic Games and Unity. Our main task is optimizing game engine. When we work with engine company, we applied our optimizations into their engine. So some of our optimizations are already spread to the market. And when we work with game company, we provide them our custom engine, which has specific optimizations of their game. Another work we do is device loaner program. We helped our partners by providing our Galaxy devices to help their development and testing. And many developers who worked with us have difficulty with handling mobile profiler like DS5 and Snapdragon profiler and RenderDo. We support them to profile their game because we have many experiences of handling those tools, and we also share our experiences of handling those tools. We support them both remotely and by on-site camp. We have 5 teams in global: USA, UK, Ukraine, China, and Korea. We have many histories of on-site dev camp. So it is the pictures of it. And these companies are our partners. We are not only collaborate with big company, but also collaborate with small company if they have potential and good quality. This is our collaboration history. When we prepare to launching Galaxy S7, it is the first Android device that supports Vulkan. We collaborate with Epic Games to make a Vulkan demo. And last year, we worked with Epic Games again when we prepared to launching Galaxy Note 9. We support them to port Android version Fortnite. Like this, we try to spread Vulkan to the market to give a better experience to mobile game user. Next, my colleague Oleksii will talk about game optimization best practices.
Thank you, Munseong. Hello, everyone. I'm Oleksii from Game Dev Ukraine. So, a few years ago, it was impossible to imagine games like Call of Duty, Fortnite, PUBG on mobile, such high-performance games with PC-like quality level. And even today, even now, there are so many challenges for mobile game developers. So, we're still limited in power budget, as device is not permanently plugged, and performance in terms of fill rate is still mainly limited by memory bandwidths. And there is no good way for now for efficient cooling system, so thermal throttling is still an issue. So because of all of these hardware limitations, technologies now are important more than ever. Only by optimizing your game more and more, you can overcome these limitations. But traditional game optimization is just a kind of trade-off between quality and performance, which might be not enough these days as users' expectations from your game contents are very high. So how to try to get both quality and performance in your game? We think that Vulkan might be one of the solutions. So this is the next level API compared to GLES, and we believe this is the future of computer graphics for quite a long period of time. So why Vulkan is so good? Let's try to compare it with OpenGLES. So OpenGLES uses a single global state and must recreate all necessary render states and resource binding tables for every draw call that is made. And because of this, some optimizations on driver side might be very expensive or difficult to apply. Vulkan instead uses handle-based states known as descriptors, allowing the application to prepackage all all used states ahead of time. So compiled pipelines combine all relevant states, and this allows shader-based optimizations to be applied more predictably and for lower runtime cost. So this helps to significantly reduce CPU overhead. And by allowing CPU load, you can utilize your GPU much more efficiently. So with Vulkan, Vulkan gives you much more balanced CPU and GPU usage and higher performance, of course. Probably the key feature of Vulkan is its explicitness. So you can tell driver precisely what and where you want to be done. For example, you can decide when do you want to acquire next image to be drawn to. In some cases, it might be very useful to pre-acquire next image in the end of the current frame instead of the beginning of the next one. In multi-threaded renderer, when heavy frame was happened, in case of ordinary acquire, you have to wait for the next image, and only after that you will start doing all heavy jobs. But with pre-acquire feature, you can easily skip this waiting time and start to proceed all rendering commands immediately. So your frame time will be dramatically reduced in this case. Also, you can organize your own memory management. For simple demos, it might be enough simply to allocate raw data to new VK buffer every time when it is required. In this case, you need to set up descriptors for these resources and update them by descriptor sets, and only after that you may draw. For some engines where architecture is more complicated and performance is more important, it's better to use a single VK buffer and allocate raw data with some offsets in it. In this case, you can reduce allocations count, but this is still not the best solution, so you can improve it by adding dynamic offsets logic. In this case, you also will skip updating descriptor sets frequently, so you will allocate one single descriptor set for whole VK buffer, and after that update it once, and later you may just bind the descriptor sets by using dynamic offsets for proper resources. Explicitness is a really good thing, but you have to be very careful with it. Android ecosystem is quite complicated. There are so many devices with different hardware and different feature sets, and even two devices might look similar. They still may have different chipsets or different driver versions. So in case of OpenGLES, all these differences are handled with driver for extra performance cost. With Vulkan, you may customize your render for each particular device, which gives you maximum performance for each device. But in this case, you have to make much more efforts. So this is probably the only disadvantage of Vulkan, that it pushes a lot of responsibility on application side. So it is very easy to make mistakes sometimes or make some things unoptimal. For example, OpenGLES has no concept like render path object, but this is very critical for tile-based renderers. So In case of OpenGLES, driver must infer which rendering commands form a single render pass. And this task takes some processing time, and it relies on some heuristics which might be inaccurate. Vulkan has such concept, and with render passes you can specify for input and output render targets which data should be loaded, which data should be stored. So you can specify a variety of color attachments and depth stencil attachment, and with VK attachment description structure you can specify load and store operations for that attachment. So it's always worth to remember that if you don't need to read initial data from frame buffer from your attachment, so the best way you can go is to use load operation don't care. If you do not draw to entire frame buffer and just use a small area, there might be some rendering artifacts in the areas where you do not draw to. In this case, in the beginning of render pass, you should specify a load operation clear for clearing the entire frame buffer with user-specified color. And do not use a load operation load unless your algorithm really relies on initial frame buffer states. Similar is for store operations, so store only attachments you really need to store, otherwise use store don't care. Let's talk a little bit about possible power budget and benefits you can get from Vulkan for each case. So generally there are three cases. We might be either CPU, GPU bounded, or normal case, not bounded case, which is obviously the best one. So by using Vulkan API, you may improve your performance for CPU bounding case and for normal case. But as GPU hardware is still same and GPU rendering techniques exposed by Vulkan are almost identical to OpenGLES, it is unlikely that you will get any benefits if you are GPU bound. In this case, the best thing you can do is to work with your content. First thing you should pay attention is shaders. So mobile GPUs use Oleksii algorithm, which improves GPU performance by reducing fragments redrawing. But this Oleksii algorithm might not be executed in some cases to preserve correctness. For example, if your fragment shaders contains discards, if Oleksii is enabled, it will write to the depth buffer before fragment shaders start execution, and therefore depth buffer data will be incorrect. So in this case, Oleksii will not work. And same for alpha to coverage technique and for writing to depth buffer. If you will use that, Oleksii will not work, so be careful with it. Also, you have to choose your performance quality, your performance target very carefully. So let's say you're targeting HD resolution and 30 FPS. Simply by increasing your resolution to Full HD, your GPU load will be increased about twice. And if you're targeting Full HD and 60 FPS, CPU load will be increased about twice, while GPU load will be increased more than 4 times. So should be careful with that. And if you're using engines like Unity or UE4, there are a variety of quality settings, so you can set up your game properly for correct target. And another good thing about Unity and UE4 is that they already both support Vulkan out of the box, and not just support, but they have well-optimized Vulkan renderer. So just by few clicks, you can easily enable Vulkan and get all benefits from it. Here is some video of Fortnite performance optimizations. So with Vulkan, we got up to 20% faster frame rate. So all this is good about these optimizations, but it is very important to understand their impact on your game. So Munseong will tell you more about some profiling tools which are very useful.
Hello again. Last few minutes, I will introduce our new mobile game analysis tool, GPU Watch. one of our team's main goal is providing better environment to developers, so we made this tool. Before talk about GPU Watch, I want to show you common tools in market. The first one is RenderDoc. It is very powerful tool to analyze structure of GLES and Vulkan API. We can see the structure of render passes and the load and store operation of render pass, as Oleksii mentioned. And we can check the status of pipeline. And also we can see and edit the shader code on the fly. The next one is GameBench. It is very convenient tool to check performance. Although these tools have many strengths, as I mentioned, but in some point they have weakness. That is, it requires root permission to get full support, and some of those tools don't give us real-time feedback, and we have to connect a mobile device to PC. GPU Watch is targeting that point. GPU Watch don't require root permission and connection to PC, and it gave us real-time feedback. And we don't have to install extra program because it is already embedded in our Galaxy device. Let's see what we can get from GPU Watch. At the top left corner, we can see the current and average FPS. So we can check the frame drop position while you change the scene. And at the top right corner, you can check the CPU and GPU utilization. And the bottom side informations are periodically captured information. And the left middle side is the elapsed frame time of that captured frame. The green area is the render pass information. The first green bar is information of draw core count and payload count of each render passes. And second green bar is the portion of each render passes. For example, render pass number 0 has 60 draw core and about 170,000 payload count. And the number 0 render pass has 5 times more larger volume compared to render pass number 1. And the blue and the brown one is vertex and fragment activity. This is the way to enable GPU Watch. At this time, GPU Watch is only supported on Galaxy S9 and Note 9 and S10. We are trying to spread to other devices now. You can enable in Android developer options. When you turn on the GPU Watch and select the application, what you want to monitor, then select the proper rendering API of that application. Then you can use the GPU Watch after launching the application. I will show you the example of GPU Watch usage. This is the sample project we made. I will put 2 optimizations into it. The first one is merging render passes into one render pass as multiple sub passes. The second optimization is applying pipeline barrier. It makes some sub passes run concurrently. Let's see what we can observe from GPU Watch after optimization. At first, you can see the multiple render passes are merged into one render pass, and you can also check some part of a vertex and fragment activities are overlapped. It means some sub passes are running concurrently, and the FPS is changed from 20 to 50. Like this, you can get the state of mobile game in real time with GPU Watch. This is what we prepared. If you have any question, please ask us. And if you want to contact us, please send an email to this address. Thank you.
Munseong, nice to meet you.